good news about decimals is that they are actually a very small part of your exam. In fact, most often when you see a decimal, your first step will be to either convert it to a fraction or scientific notation where you can use the rules of exponents. If you're in a situation where you want to turn a fraction into a decimal, you really have two options. One, you could divide the bottom number into the top number. So in this case, you would divide 5 into 6. If you have a calculator or you're good at long division, that might be a good option for you. If you don't have either one of those options, a shortcut I like to use is changing the bottom into 100. So in this case, I can multiply the 5 by 20. But because I don't want to change the value of the fraction, whatever I do to the bottom, I also have to do to the top. So I multiply top and bottom both by 20. The ending fraction is 120 over 100. From that point, I take my numerator, 120, I have a decimal, and then I move that decimal in 2 positions from the right. So my new answer is 1.20, or 1.2. When I want to turn a decimal into a fraction, I use the same process, only in reverse. So I take my decimal and I move the decimal 2 positions to the right. I take that number, which in this case is 12, and I write it over 100. Then I try to simplify my fraction. In this case, I can see that I can divide both 12 and 100 by 4. So my fraction becomes 3 over 25. When you're dealing with very large or very small numbers, you may find it advantageous to use scientific notation. Scientific notation likes to see exactly one number to the right of the decimal. So in this case, 0.00072, scientific notation would like to see as 7.2. Well, how do we do that? How do we get that small number into a bigger number? Well, we move the decimal over 1, 2, 3, 4 times. When you move a decimal to the right, you are multiplying by 10. So in this case, we multiplied by 10 4 times, or we multiplied 0.00072 times 10 to the 4th. If we want to take 7.2 and convert that back into 0.00072, then in that case we're going to divide by 10, and we'll divide by 10 4 times. You write dividing by 10 as 10 to the negative 4. Since we don't want to accidentally change the value of our numbers, we need to make sure that when we say 7.2, we're actually talking about the much smaller version of 0.0072. So we say the number we're talking about is 7.2, then divided by 10 4 times, or times 10 to the negative 4. In this case, they've started us off with scientific notation. If we want to take this number, 3.6 times 10 to the negative 3, and convert that back into a decimal, we simply have to understand what the 10 to the negative 3 is doing. 10 to the negative 3 is dividing by 10 3 times. And remember, each time you divide by 10, you move the decimal to the left 1 position. So in this case, we're going to move the decimal to the left 3 positions. 1, 2, 3. In order to do that, I actually have to add decimals. So my new number is 0.0036, where the decimal is 3 positions to the left of where I started. You should also be familiar with the rules for multiplying and adding decimals. When you multiply decimals, you need to make sure that the number of digits to the right of the decimal is the same before and after you multiply. So in this case, we want to simplify this 0.2 squared and this 0.2 cubed. Well, 0.2 squared is the same thing as 0.2 times 0.2. I know that 2 times 2 is 4, but because I have 2 decimals to the right before my multiplication, I need to make sure I have 2 decimals to the right after my multiplication. So 4 actually becomes 0.04. And likewise with 0.2 cubed. 0.2 cubed is the same thing as 0.2 times 0.2 times 0.2. I know 2 times 2 times 2 is 8, But in this case, I have to make sure I have 3 digits to the right of my decimal. So my answer is 0.008. Now, when I add all these numbers, I simply make sure my decimals are all aligned. So I write my first number as 0.2, my second number as 0.04, and my third number is 0.008. And then I just add straight down. In this case, the math looks quite easy, so I get 0.248.